Welcome to Databricks. In this lesson, we are going to learn the fundamentals of Databricks Notebooks. A notebook is where you write code, run commands, document your logic, explore data, and build repeatable data engineering workflows. Let us start from the workspace area. This is where Databricks organizes notebooks, folders, files, and other workspace objects. To create a notebook, click Create, then choose Notebook. Databricks immediately opens a new empty notebook for you. At first, the notebook has a temporary name, so let us rename it to Notebook Basics. Using a clear name is important because it makes the notebook easier to find, share, and understand later. Now the notebook is ready. By default, Databricks selects Python as the notebook language. Python is very common for data engineering and PySpark work, but Databricks notebooks are not limited to Python. They can also run SQL, Scala, and R, depending on what you need for the task. For this lesson, we will keep Python as the default language. Before running code, the notebook needs compute. Compute is the processing power that actually executes your commands. At the top of the notebook, you can attach an available cluster or use serverless compute if it is enabled in your workspace. Once the compute is attached and ready, the notebook can run code interactively. This is one of the reasons notebooks are so useful for learning, testing, and development. You can write a small piece of code, run it immediately, inspect the result, and continue improving your logic. A Databricks notebook is built from cells. Each cell can run independently, which makes the workflow flexible. Let us type a simple Python command that prints a Hello World message. To execute the cell, click the play button. You can also use the keyboard shortcut Shift plus Enter. Because the notebook language is Python, Databricks interprets this command as Python and displays the output directly below the cell. This confirms that the notebook and compute are working correctly. To continue building the notebook, add a new cell under the current one. Now let us try something different. We will write a SQL statement inside this Python notebook. When we run it as a normal Python cell, Databricks returns a syntax error. That happens because the cell is still expecting Python code, not SQL. To fix this, change the language of the cell from Python to SQL. Run the cell again. This time, the SQL query executes correctly. Notice the % at the beginning of the cell. This is called a magic command. Magic commands provide special notebook functionality regardless of the default notebook language. In this case, the language magic command tells Databricks to execute the cell as SQL, even though the notebook itself is configured as Python. This is very powerful because a single notebook can combine Python, SQL, Scala, and R in different cells. Another useful magic command is Markdown. Markdown is used to add formatted documentation inside the notebook. This is important because real data engineering notebooks should not be only code. They should also explain what the code is doing, why it exists, and how the workflow is organized. With Markdown, you can create titles, bold text, italic text, ordered lists, unordered lists, tables, images, and hyperlinks. This makes the notebook much easier to read and maintain. After editing the Markdown cell, exit Edit mode to see the formatted result. Now the notebook contains structured notes, not only executable code. Markdown titles also appear automatically in the notebook table of contents. This is very helpful when a notebook becomes long. Instead of scrolling manually, you can use the table of contents to jump directly to the section you need. Next, let us look at notebook modularity. In Databricks, one notebook can call another notebook. This helps you avoid repeating the same setup code in multiple places. For example, create a folder named Includes. This folder can store reusable helper notebooks. Inside that folder, create a notebook named Setup. In the Setup notebook, define a simple variable. This represents reusable setup logic, such as parameters, paths, common functions, or configuration values. Now return to the main Notebook Basics file. From the main notebook, use the Run Magic command and reference the path to the Setup notebook. When the reference notebook runs, its variables and declarations become available in the current session. To confirm this, print the variable that was created in the setup notebook. The value appears successfully. This pattern is very useful because it helps organize code into reusable components. Instead of building one giant notebook, you can separate setup logic, utility functions, data preparation steps, and analysis logic into different notebooks. That makes projects cleaner and easier to maintain. Databricks also supports file operations from notebooks. One option is the file system magic command. With the %fs command, you can list files and folders directly from a notebook cell. Here, we list files from the Databricks sample datasets directory. These sample datasets are available in every Databricks workspace and are useful for practice, demos, and quick experiments. The result shows the folders and files inside the selected location. Another option is dbutils, which stands for Databricks Utilities. dbutils provides helper commands for interacting with the Databricks environment. You can work with files, secrets, widgets, credentials, notebook workflows, and other services. To explore what is available, use dbutils.help. For file operations, one of the most common utilities is dbutils.fs. With dbutils.fs, you can list files, copy data, move files, and remove files directly from a notebook. Databricks also provides autocomplete, which helps you write commands and paths faster. This is especially useful when working with long folder paths or utility functions. So which one should you use for file system operations? The %fs command is simple and convenient for quick exploration, but dbutils is usually more flexible because it works naturally inside Python code. For example, you can store the output of a file listing inside a Python variable. Then you can loop through the files, filter them, validate them, or use the result as part of a larger workflow. If you print the raw output directly, the result can be difficult to read. Instead, use the display function. Display renders the output in a clean tabular format. Now you can see useful metadata such as the path, file name, size, and modification time. The display function can also help with data exploration. Depending on the data, it can show tables, support exports, and even create quick visualizations. This makes notebooks practical not only for engineering, but also for debugging and analysis. Finally, let us look at portability. At the end of your work, you may want to download, share, or back up your notebook. From the File menu, you can export an individual notebook as an IPython notebook file. You can also export an entire folder as a DBC archive. A DBC archive packages multiple notebooks and folders together. This makes it easier to move notebook projects between Databricks workspaces. To bring notebooks into another workspace, use the import option and upload the exported file. One final feature is revision history. Databricks automatically keeps track of notebook changes as you work. By opening the revision history, you can review previous versions and restore an earlier version when necessary. This is very useful when collaborating with other engineers or when you need to recover from a mistake. And that is the foundation of Databricks Notebooks. You learned how to create a notebook, attach compute, run cells, use multiple languages, document with Markdown, reuse notebooks, work with files, use dbutils, display results, export notebooks, and restore previous versions. Thanks for watching, and I will see you in the next lesson.